Okay, Mikaya.
Okay. So good morning. It's 10:30. Good morning and welcome to all the viewers and participants joining us on Master University Facebook page and YouTube channel. We are delighted to have you here for the Wiper series hosted by the Faculty of Engineering, Built Environment and Information Technology at Master University. My name is Mikaya and I am honored to be your moderator for today's session. Our featured speaker for today's Wiper is Mr. Muhammad Zulhari bin Maud Khosrow. Muhammad Zulhari bin Maud Khosrow is a civil engineering lecturer at the Faculty of Engineering, Built Environment and Information Technology at Massa University. With over 5 years of experience in the field of civil engineering, he focuses his teaching and research on material and structural engineering. His research primarily focuses on finite element analysis, green concrete material, and structural engineering. He earned both his bachelor's and master's degree in civil engineering from University Tun Hussein on Malaysia. Without further ado, I would like to welcome Mr. Muhammad Zulhari, who will be speaking to us with the topic Bridging the Gap, Finite Element Method Application in Civil Engineering. All right, Mr. Muhammad Zulhari, the floor is yours.
All right. Thank you so much, the moderator, Mr. Mikaya, for a warm welcome. Right. So for the audience, Assalamualaikum and very good morning. So actually, my name is Muhammad Zulhairi. I'm a lecturer at the Civil Engineering Department in Faculty of Engineering, Development and Information Technology at Massa University. Alright, so my session today, okay, I will give a sharing session about topics titled Bridging the Gap, Finite Element Method, or in nowadays we call as an FEM, Applications in Civil Engineering. Actually, there are a lot of method or there are lot of terms, okay, how to pronounce the finite. Sometimes myself I call as a finite, and sometimes they will call also finite, and there is many terms or many tones on how you can call it, right? But however, after I have checked through the Googles, right, there the correct terms to pronounce is the finite element method, or basically I call it a short form as an FEM. Okay, so I'll try to sharing my knowledge as much as I can. That the final one is to elevate the gap between the application in civil engineering and also all of the challenge and so the advantage. So next slide. Alright, so in a general, okay, what is FEM? Right, so as I mentioned, FEM is a finite element method. Sometimes also they will have finite element analysis, FEA. Sometimes also we call it as FE only, finite element. So it can be finite element analysis, finite element method, even computational studies, and also sometimes the terms is more direct. Direct means they are called as a non-linear analysis or linear analysis, a static analysis, a dynamic analysis, and so on. Right? But the main terms in the FEM, it is depends on what are the type of software that you will use. Right? So we have a lot of software, right? And then we have a lot of terms. So for this specific session, I will just only focus on the terms of FEM. All right. So what is FEM? So basically, FEM, it is in a simplest term. Okay, in a general terms, it is a method that used to break a big complex problem into smaller and simpler parts, and then you to solve it step by step. What it means that imagine you have one phone, okay, or you have anything else, even if you have any objects. all of these objects, they will have like a one rectangle cube or one small cube we call as a smaller part. Okay, so that is the smaller parts or a simpler parts. This cube is sometimes termed as the elements. So that's why it comes the terms finite element method. Meanings that the element, okay, the interaction between the element, everything is interconnected, right? So between the elements, they will have the basics knowledge of mathematics that you have learned during our primary school, during our secondary, even also in the tertiary education also, we already learned about their calculation, right? So basically, and then all of the calculation is being combined, and you can see the result, or you can analyze, or you can visualize how the whole structure behave. Okay, so FEM in a general term, that's it. From the biggest part or the biggest object, you are breaking the object into smallest part. All right, it is called as elements. All right, and then the elements was interconnected between each other. So it will be interconnected through what we call a mathematical equation. Then after it has been calculated, you can view all the result and you can see how the structure is behave. That is the general terms of FEM. Alright, for the next slide. Alright, so in a general, after you have visualized the object, after you have modeling the objects in the software, why we need to have the FEM? Okay, why the finite element method is very important in the engineering analysis. So as a modern nowadays, okay, as a modern era or modern technology nowadays, okay, the people keep on want to have much more simple software, okay, much more simple solution. So in the slide, there are some of the importance of the finite element methods in the engineering analysis. Okay, when it comes to engineering analysis, meanings that it will involve all the calculations, all the theories, all the limitation, and so on. Okay, so the first important is the capability of the finite elements to handle complex problem. Sometimes the complex problem comes from a, we call it as an intricate geometries, or what we call geometric shapes that does not have a fixed shape. So the geometries sometimes with the object comes with a different materials behavior, right? For example, we have a building, okay, we have a concrete parts, we have the steel parts, we have the soil parts, even we have the plastic parts. So all the materials behavior must be run or must be defined in the software, FEM software, before to do the analysis, right? But then, by the means of the FEM software, it will be automatically set in the software just to have the final analysis and result. Also, in the terms of handling complex problem, okay, sometimes the when you are modeling the object, okay, you need to face with a different boundary condition, right? Sometimes in engineering we have different types of support, we have different types of loading, and then we have different types of any other properties that is very hard or very difficult if you want it to do manually calculate. Okay, so all the difficult work have been done by the FEM. So that is the first point of why the FEM is important in the analysis. Right. Next is the prediction. Okay, where the accurate prediction on the FEM result is very important, because when you are dealing with one of the engineering analysis, okay, you will face with various end user, mostly people. So that's why you need to have the accurate prediction to do the simulation. So basically for the prediction, it will provide a details and precise, okay, insight into what is the type of force, either it is a stress or strain, all the deformation, all the heat transfer, and also all the flow process. Okay, I will explain more on the later on, because in the civil engineering we only focus on several key areas. Okay, then the third one is on the design optimization, the importance of the FEM in optimizing your design. So basically, it will help to improve your design by testing various scenarios and materials without physical prototypes. Meaning that compared to when you want to conduct the actual projects, so instead of you are building the expensive prototypes, okay, you can just using the FEM software to model the object, you test the object, and then you can put a lot of case scenarios to see what will happen when there are certain testing have been conducted towards the object, right? Then the fourth one is the cost and time efficiency. So it will reduce the need for physical testing, and you can accelerate the design process. Meaning that instead of you are taking a lot of time just to build a prototype, then testing, if it is failure, then you need to redo again the prototype. So you can save the time by using the FEM software to do the analysis, right? Then the next point is the multidisciplinary application. So the multidisciplinary application, because we can work with various fields. We can work with um, aeronautic field. We can work with engineering, civil engineering field. We can work with the uh, mechanical, electrical, and even biomedical engineering also we can work together. And then because it just some sorts of software, okay, so everyone can use the software just to conduct the analysis. All right. Then it also the important is in terms of the failure prevention, meaning that before you are running the actual objects, you can identify what is the potential engineering failure or the potential weak points or failure zone in a structure or system before you further it into the manufacturing process. And then you can have also various solution that you can customize, meaning that sometimes you are requiring different customers need that have that they want to have some different methods of solution. So you can adapt to a specific problems by you can adjusting the element size, the shape, or also the material properties of your object. Alright, and then next is the widely used in industry. So it has been mentioned as you can work with a multidisciplinary application. It is essential to meeting industry standard, and you can ensure the safety and reliability of the engineering solution. Okay, so that is the several points on the importance in engineering analysis. Alright, next point. Okay, so what are our objective today? So basically in a slides, okay, I will introduce to you a little bit about a finite element method. Okay, so I'll try to provide some of fundamental on how the FEM works, and then well, how the principle and also workflow of the FEM. Also, I'll try to highlight some significance in the engineering modern analysis. Okay, number two for our objective today is the exploring in a civil engineering application, because basically I'm from civil engineering department. So I am sorry that I only need to have okay a specific focus. It's because we have a lot of engineering fields. So in my sharing session today, I will just focusing on the civil engineering application. I will try to give you some of the picture on how the finite element method is applied in a various civil engineering domains. Okay, and then how I'll try to share some of the real world project example that have been completed and it has been successfully withstand until today. Okay, because during their construction process, that is where they are using the finite element method or finite element software analysis just to make sure that the building still stands to still until today. Alright, and then the third one, our objective today is by highlighting what is their benefit and what is their challenge when you want to have using the FEM. And then the last one is the bridging the gap, meaning that if you have what is the benefit, you have the challenge, you have all of the engineering field that will need to use the software, how you want to bridge the gap, how you want to elevate the gap, or sometimes you need to minimize the gap between all of the objective. Right. So next slide. Okay, so in this definition, it is more specific into the FEM. So as I have mentioned in the introduction earlier about a general introduction on the finite element methods. Alright, so for the definition, finite element method is a numerical technique, okay, solving complex engineering and mathematical problems by dividing structures into smaller, simpler parts. Okay, it is called finite elements, meaning that you will um, you will what we call combining, okay, combining your complex engineering theories, and you will combining also a mathematical problems theories, you combine into one full package of a software. Then the software will automatically divide the object into several parts, smaller parts that we call as a finite elements. And then these finite elements we applying loadings, okay, we applying many boundary condition, we applying a lot of what we call scenarios, a lot of environmental impact, okay. Even sometimes when you want to work with some of the fluid mechanics problems, even the wind problem also you can integrate into the software. And then don't waste your time to manually calculate it, manually analysis, okay, because the full package of the FEM software will calculate it manually for you. All right, so that's why it is what we call increasing trend in using the software, okay. And then also you can minimize the error while you are calculating the analysis and so on. Okay, so that is the definition on FEM. Okay, next. All right. So here are the historical developments. Okay, so I cannot see well through my slides because it is a little bit brighter. Okay, but as I want to mention to you, okay, about the how the usage of the finite element method is being used widely. All right, it is start from early as the 1940s until today's. Okay, meaning that it is start from the war area where they want to analyze some sorts of their military equipments. Okay, and then how in the early 1950s the engineers, okay, start to introduce the terms of the finite elements. Then in the 1960s, it's already been expanded into another field, mechanical, electrical, civil engineering, until today. Okay, and I believe when it comes to the technologies, it will keeps on revolving every day. Okay, even for today's, we have an artificial intelligence software. Okay, we have lot of helpers. Okay, we call it as a helper, just want to make our life easier, right? So basically in the engineering fields, okay, for those who are in a consultation areas, okay, and a person that every day they will involve all the all the analysis process, okay. So all of the software will make their life easier, okay. It thanks, okay, thanks to the early civilization that developed the finite element method. All right, so next slide. Okay, so in a general, okay, finite element method is classified into a three stage of processing, or what we call their workflow. So basically we will have the pre-processing stage, processing, and also the post-processing. For the pre-processing, basically it is where all of the information have been modeled. Okay, meanings that you need to define all the object mesh size. Okay, you need to define. Okay, you need to give the material properties behavior, and then also you need to give also you need to set what is the boundary condition, meanings that you want to restrain a certain parts or you want to have involve introducing some of the wind load from your left or from your right and so on. So there is the processing stage, pre-processing, meaning that all of the environmental information you are joined into a one complete modeling, right? Then after everything have been complete, okay, it will go through what we call a processing stage. Okay, this processing stage is where all the software plays their role in calculating, in analyzing. Okay, so they will have like given you what we call a certain color with a certain parts. Okay, so there is during the processing stage, okay, on how the object is being model in the software. And then the last one is the post processing. The post processing is basically in a general is just a result. All right, it is just a result. um, it is just a result that will visualize all of the result that you want, meaning that from the materials and then all the boundary conditions and then all the constraint, okay, you have introduced, then you want to see what is the final decision or what is the final result on the process. Okay, next. Okay, previously is the general workflow, but this one is like a more detailed process. Okay, it is the fundamental principle. I will highlight that I believe most of the FEM software, this is what they will be faced. Okay, basically in any finite element model software, this is what are the fundamental principles that they will need to conduct. Okay, the first one is the discretization, meaning that you are dividing the complex domain into a smaller, simpler elements. Meaning, like I give to you the example, one objects, okay, one phone, for example, you are divided into a smaller parts. Okay, so there is the discretization, and then the element formulation. You need to define what is the equation for the individual elements, meaning that what are the types of element, either it is three-dimensional or two-dimensional, and then either it is a beam element, truss element, or plane angles elements, and so on. And then also you need to define their properties and also their material behavior, right? And then it will be assembled in a global system, meaning that you are combined the smaller individual elements, you are combined into one biggest element, we call it as a global element. And then basically the global element is representing the entire objects. Okay, if you do the object, then it will be resemble a full object. And then you need to set also the constraint in terms of their boundary condition. Okay, how many supports, what are the external forces, and then also the real world scenarios, either you want to simulate it in an earthquake or in a water, in a wind, strong wind, and so on. So that is the boundary condition, or what we call the constraint that applied into your object, right? And then the solving system equation, so it will be using what we call a numerical method in the software. Okay, so basically if you have learned the topics called as a matrix, okay, a matrix that you have the row and column, then how you want to multiply, how you want to divide. Basically that is the most used mathematical equation in the finite element method. And then the last is the post processing, okay, where you can interpret the result and then you can analyze where is the part that have higher stress, where is the part that have lower strains, where is the part that deform, and where is the part that have some failure. So through the post processing parts, okay, you can, that's why it comes to the importance where you can find a solution on how to elevate the problem, and maybe you can change a little bit of the design. Okay, just you want to make sure it is suit the ability of your construction requirements. All right, even if you design later on we will see some of the example on how the FEM can be used to the importance of the FEM. Just want to have the optimizing your products. Okay, all right, next slide. All right, so like I mentioned to you, I'm from civil engineering, so I'm really sorry that I only focus on the civil engineering. Also, our topics today is more related to the civil engineering application. Okay, so in the area of civil engineering application, this finite element method can be used in these three key areas. Okay, first we have the structural analysis part. Okay, second we have the geotechnical engineering, and then also we have the hydraulic system. Okay, for the structural analysis meanings that imagine in a circulation of a wall. Okay, you have the building, meanings the structural analysis, that is the building. Then the building is being built up in a foundation or a soil, so that is where the geotechnical engineering is come. And then also you will have various condition of weather. Either you will have wind, either you have a flood, water, and so on. So that is where the hydraulic system is focused. For the hydraulic, is more on the hydraulics and fluid. Okay, so basically you will have one complete circle of an civil engineering application where you have the building, the structural analysis in the middle. At the bottom part, you will have the geotechnical engineering where it is lay the foundation and so on. And then also the wind, the the water, okay, that is comes from the hydraulic system. So that is one whole circle of civil engineering key areas. Right. So next slide. Okay. So we will go through the first one. Okay. So this is to showing to you how the finite element method is being applied in a civil engineering application. So this is some of the example on how the structural analysis FEM, okay, the FEM have been used in the structural analysis application. All right, so basically we have three example. Okay, the first one is the high-rise building under seismic or earthquake loading. Sorry. Okay, the first one is on the high-rise building under seismic and earthquake loading. Meanings on the top picture, you will see that that is how the high-rise building have been modeled in a software, in an analysis software, just to obtain what is their forces or their final axial loaded on the foundation. Meanings that they will identify which part or which design have the weakness, so they can, okay, uh, they can change the design and so on. But the problem is, how do you want to investigate when the building have been applied a seismic or the earthquake loadings, right? So that's why at the bottom picture they will showing a picture with lot of colors. Okay, whoever that have in the fields of finite element method, okay, all of this color, they will be familiar with all of this color, because it will showing you which part that have higher stress, or which part that showing higher deformation status, or which part that will prone to failure. Okay, so instead of they are producing a prototype, even the smallest building design, so they will take a longer time. Okay, so they will what we call, they will use the software, they will just draw in, they will input all the boundary condition, all the material properties, then you can get the final analysis, right? So then also, as you can see, when the high rise building is under the wind loading, okay, I believe it is must be helped with other meteorological department. Okay, any country they want to observe where the wind come off, so that's why the FEM will simulating the direction of the wind, and then also when the wind have been implied into your buildings, what will happen. So that is the impact, okay, the usage of finite element method software in terms of analysis the wind loading on a buildings, right? Then come to the third one is a bridge design analysis. Okay, basically you can use it in most of any structure. Okay, you can use it in the building, you can use in the bridge. What else? You can use in the road. Okay, in the road also it is very useful. Even the hydroelectric dam. Okay, what else? Turbine power plant system at the seesaw. Also, there is the example of structural analysis application, meaning that instead of you are using the manual calculation, which sometimes it may be elevate to the highest calculation error, because if we are human, we are not cannot run from the mistake. So you are using the software, and then the software will calculating without the error. Right. Okay. Next slide. Alright, so the next is about some of the previous case study, okay, some of the example that have been using the finite element method in their project, okay. So as you can see, there is a Milau viaduct, okay, a long bridge in France, okay. They are analyzing the bridge in terms of their design, and then the project, okay, they are using the finite element method. They analyze the Milau viaduct in the France. Okay, so their main focus is to evaluate the stress distribution. Okay, for sure when they are bridge. Okay, there are a lot of heavy vehicles that always using the bridge. Okay, and then as you can see also it is a high rise bridge, so they need to identify the wind load effects and also how the structural will behave, either it is stable or not when the loading is applied, right? So from the project, okay, the design we can improve to withstand extreme environmental condition, meaning that you have been simulating the very extreme condition of environmental, and you didn't change the materials, you just only change the design. Okay, so how you are expecting the outcome, it is depends on the finite element method. So after the finite element, after the simulation progress have been completed without any error, so they will proceed. And I believe this Milo Viaduct is still stand until today. All right, next slide. Okay, for the next slide, I believe everyone knows. Okay, the Burj Khalifa of Dubai. Okay, so for this Burj Khalifa, they are using the finite element software to analyze their structural system, and then same cases happen during with the bridge previous slide. Okay, where you will need to access the wind resistance and also some of the seismic performance. Okay, even if the area is not have what we call earthquake activities, okay, but currently in standards, okay, we are needed to implementing adding or what we call an adding an analysis on the earthquake or basically a seismic in terms of our calculation. Okay, so by then this software will analyze the Burj Khalifa design, and then for sure it will have also the different material behavior. So by then the structural system can be optimized, and then it will be safety, and also the material can be reduced. Okay, and then this building also I believe is still standing until today. Okay, so next slide. All right. Okay, so the next slide is about a structural also, but not a structural parts of a buildings of any structural buildings of any construction. Okay, so it is the example of the analysis of aeroplane wings. Okay, where you will need to identify, and then I believe the main material for the aircraft is a steel. So they will examine the deformation or the stress under aerodynamics load, because the aeroplane is moved based on a thrust system. Okay, based on the thrust system that have been generated by their turbine engine. So they will facing a lot of a wind. Okay, sometimes they are snowing, sometimes they are raining. So all of that will take into consideration in the analysis. So they need to design the most optimum design of the wing for that they can work under various stress conditions. Okay, so um, the material must be a lightweight, okay, but must be a robust wing design, so they can also enhance the fuel efficiency and performance. It cannot be too heavy, and then it cannot be too lighter. Okay, it must be in a optimized design. So by then, the aeroplane can bring you to anywhere in this world. Right. Next slide. Okay, so here are the advantage over traditional methods. Okay, like our main focus is to bridge the gap. Okay, we have the solution, but we also have the challenge. Okay, so when we are using the finite element software in this structural analysis, what are the advantage? Okay, the first one is it can handle a complex geometry, where I believe I already mentioned in the importance, where the FEM can be uh, they can simulating or intricative the structures or any irregular shapes that are very difficult for traditional methods analysis. All right. Then number two, it is an accurate and detailed result where we can provide a localized insight, and then such as stress concentration. Okay, meanings that is we can view where is the stress failure happen compared to the manual calculation that we cannot see the visualization. Okay, and then the third one, we can solve a multi-physics problems. Okay, where you can similar to, okay, where we can calculating the structural analysis problem, thermal problem, fluid resistance, wind, and so on. So we can combine all of these multi-physics problem, and then we will have one complete solution. Okay, and then the fourth advantage is on the time and cost. Okay, where you can save your cost, we reduce the extensive physical testing and prototyping. So like I said, instead of you are using or you are wasting money and time want to have a prototype, so you just can visualize in the software just to get the final time and cost. And then also you will have a flexible and adaptable, meanings that you can modify your design. Okay, you can adjust a material change, you can put any loadings. Okay, and then also you can change types of the boundary condition and so on. It depends on because of that is your design. So as a designer, you can put various condition and so on. And then also automates a repetitive task. So for this one, you can use the software for in one time you can use for the machine size, and sometimes you can use for solving another parts of the problem. And then also you can view the result, and then also you can save significant effort, meaning that instead of your effort just to manual calculate, you just use the software, so you can it will be what we call multi, what we call it, uh, you can handle in a multiple ways. Okay, we multi-purpose, okay, multitasking or what we call. You can solve the physics for chemical, you can solve the physics for the structural parts, you can solve the physics for the materials part. And then also for the modeling, you can model your object into a larger models, larger or smaller. It's up to you. If you have like the example of the Burj Khalifa Dubai, can you imagine how the tallest building in the world if been simulating in the software? So yeah, the software, the computer is just a small one, but you can visualize a larger models. And then also the final advantage is to improve the design optimization, where you can facilitate the iterative analysis for enhancing the structural performance and reducing the material use. Meaning that you can change into several material use, and you can change the specification of the materials because you want to choose the cheapest one, but yet the robust one. All right, next slide. Okay, next come to the second key areas in a civil engineering, okay, where it is more focused on geotechnical, okay. So for this geotechnical, basically, for the example, how the finite element method is being used to identify what is the interaction between the soil and also the structure parts. Okay, so and then also the slope stability analysis. I believe if in the area that have a mountain area that have a slope area, okay, where sometimes when there are heavy raining, okay, the soil structure will be weak and it is very dangerous as the land can be collapsed or landslides, right? So by then we need to have a very good slope stability analysis for the engineers to reduce the problem. And the most important is not the most important, the most important example is the tunnel design, how your subway station train is being can be simulated to withstand all of the bearing capacity of soil under the during the construction. Okay, next slide. Okay, so the first example is showing you about a virgin dam slope Italy. Okay, so basically the project is about a slope stability analysis. So actually, it is have been existed in a long time. Okay, because it is a natural man-made slope. Okay, so it is some of the example of slope that have been constructed by a man-made. And then they will need to predict what is their potential landslide by modeling the soil strength and also the water pressure interaction. So as I will mention that this software can work, okay, it can be operates together in a different application. So in this one, they will predict potential landslide basically for the geotechnical engineers and also what are their relation with the water pressure interaction between the water engineers. So these two professionals, they can work together just to predict what is the potential of the landslide, right? And then that is the example there by the Vajon dam slope in Italy. Okay, they will need to improve their slope reinforcement. Okay, next slide. Okay, this is the second example of geotechnical engineering that using the finite element. So basically, if I read this story, okay, it is about an undersea channel. Okay, it is a longest channel that connecting between the United Kingdom at the left hand side into the France at the right hand side. Okay, they are connecting two countries. Okay, through a undersea channel, undersea tunnel. So they design the underground tunnels in urban areas. Okay, because they cannot use in the uh, top surface area. So they are producing a undersea channel. So can you imagine how the channel, how the tunnel is being constructed under the sea? Okay, but then the problem, not the problem, basically in the application is to analyze what is the stress redistribution of the soil, of the water, of the hard ground strata into the tunnels during and after the excavation. Meaning that during the processing, okay, the machineries is running. Before that, we need to identify what is the material behavior on that particular areas. Okay, so that's why they are using the finite element method in critically, okay, modeling the structural integrity of the channel tunnel. Meaning that you have UK, you have France, that you want to have the connection. So the problem is you didn't know what is under the sea, what is their behavior of the um, geotechnical field in that construction. Okay, next slide. All right, then the next is about technical engineering also, but this one is more focused on the foundation. Okay, I believe everybody knows the highest twin tower in the world, Petronas Twin Towers. Okay, so the scenario or the using of FEM in terms of their optimizing their foundation design. Okay, optimizing their piling, their foundation for heavy structures. Okay, so that is they are using the finite element method to analyze how the foundation will work during the construction or during the entire life. So They are investigating the foundation by integrating all the data about the soil, structure, interaction, and how the land settlement. And then for sure when you're doing a piling, you need to embed a piling until the hard strata, okay, until the hardest bedrock. So that's why in the finite element method, you need to investigate first either this area or what are the suitable size to build the foundation. Okay, so next slide. All right, so can you imagine when you want to do some of the analysis in a soil, okay, in a geotechnical engineering, so and then also combine with the analysis or the manual calculation of the structural part, structural analysis. So it is very, very time consuming, and then also it is will increasing calculating error because it is being calculated manually. Okay, and then for this one, we will have seven advantage of traditional methods. So basically for this one, it is almost same with the advantage when you are using the FEM in the structurals, but only this one, the advantage it is in terms of the geotechnical engineering. Okay, so the first one, the complex geometry handling. So the FEM can model the irregular terrains, okay, the terrains, the different slope, uneven surface of the slope, and also the underground structure with ease, meaning that you can analyze it very, very easy because when you are manual calculation, you will have different type of slope, different surface of terrains, okay, irregular surface, and you also a different foundation profile and so on. So you can use the FEM and you can calculate it easily. Okay. Number two is the material non-linearities. Okay. So the software can accurately represent the soil and rock behavior. Okay, they can identify the plasticity, the anisotrophy properties, and then I believe in if we are using the traditional methods, you need to have a lot of testing. Just want to identify the several properties of the materials. Okay, the third one is the versatility in load condition. Okay, sometimes you can apply a dynamic loading, you can apply a seismic loading, you can apply the any realistic event of loadings. So that's why there are various offloading or impacts that you can what we call you can include in the analysis process. Okay, then the fourth one is a detailed stress and deformation analysis where all of the failure in terms of stress, in terms of bearing capacity, friction between your pilings and the soil, everything it can be analyzed through the software. And then also multi-physics integration where you can coupling with some types of phenomena. Okay, for example, like you want to analysis the soil structure interaction plus with the groundwater seepage, meaning that the groundwater table have increased. What will happen to your soil interaction, soil structure interaction? Either you can visualize it in terms of a three-dimensional or you can visualize it in a two-dimensional, right? Then the time efficiency, for sure we want to save in a time, so we just straightforward using the software. Okay, in a matter of time we just click, then we can get the result. Okay, then visualization of result, meaning that in the same also you can use a color codings, okay, just to identify which part have the problem and which part have the least problem, so you can play around or you can adjusting some certain of parts, okay, to make sure that your design is useful. Okay, next slide. Okay, this is the third key areas that implementing FEM in their construction, in their process. Okay, we call it as a hydraulic and sometimes a fluid structure interaction. So we have covered the structure analysis, which is the object. We also covered the foundation. All right, basically we using what we call soil. Now is either a fluid or a wind. Okay, so basically it is most usually in a dam analysis and modeling, because in a dam we have a combination of the structure and also the fluid. Okay, all the water pressure, all the soil pressure, all the environmental pressure need to be analyzed before it is finally be constructed. Okay, next slide. Okay, so this is some of the example why we need to use the FEM in the um, hydraulics and fluid structure interaction. So basically, we need to analyze the stress and deformation analysis of a dam. Okay, we have the pressure from the water. Okay, sometimes we have the seismic loading. Sometimes we have the earthquake. Even also the temperature change also can be affecting the structural integrity of the dam. So you need to have, you will use the FEM to enhance the safety design to prevent their structural from failure. Okay, so that is why FEM is used in the dam safety project. Okay, next slide. All right, next slide is about offshore wind turbine foundation. Okay, so when wind turbine it is worked with a wind loading, and also as you can see it is in the middle of the sea, and then also for sure it must be built in a strong foundation. So you need to have a good bedrock strata to make sure that the wave, the wind and seabed interaction is not affecting your wind turbine foundation. Okay, so it is also can be used to optimize what is the suitable material, how big your wind turbine, and how that your construction phase will be for the wind turbine construction. And then also you can analyze for its stability and durability. Okay, because water, as you know, they will have a very high uh, acidic content because it is a salt water. So it will create what we call corrosion to the wind turbine. Okay, next slide. And then this one is under the sea, so it is very famous in terms of what we call oil and gas industries, where you need to install a pipeline and subsea structures. Okay, sometimes also our internet cable that have been gone through from country to country. So there is also the projects that is relevant in using the FEM. And then also you can evaluate what is the water pressure when it is dropped very down in the bottom of the sea, and then what are the effects that have been given from the temperature rising. Okay, and then the soil pipe interaction in the sea base. Okay, so that is you using the FEM just to skip on using to analyze the problems. And then durable pipeline system for transporting fluid in harsh environments, meaning that you are want to transferring what we call any fluid, okay, any important fluid from one place to another place. Okay, instead of you are using a normal boat, you are just transferring using a pipe. But the problem is you need to identify all the geophysical properties under the sea. Okay, what are the suitable material for the pipeline and so on. Even also you need to have what are the factors that will affect the failure of the fluid structure interaction. Okay, next slide. So here is the advantage of hydraulics and fluid structure interaction when you are using the finite element method compared to the traditional method. Okay, so the first one is the accurate simulation of complex behavior. For sure, you will have involving a various field of engineering, various field of construction. So you will need to capture the dynamic interaction between the fluid and the structure, and then also you need to take also account into a non-linear effect and transient behavior, meaning that sometimes this water can be have a different with this material and so on. Okay, next is the versatility. Okay, how you want to handle a wide range of problem. Okay, from the steady state water into a transient flow, and then also some of the solid deformation that will happen or will appear at the bottom of your construction parts. And then also how you are uh, the versatility can be also happen to a various materials. Okay, you can use a non-linear materials or what we call a composite materials or prefabricated materials and so on, but you need to understand well how to include it in the FEM software. And then the cost and time efficiency, okay, when you are using the FEM over traditional methods, okay, you can reduce the need for expensive physical model and prototypes. So it is same from the previous key areas that use FEM. You want to save time and you want to save cost from building the prototype. And then you will have the detail inside. Okay, you can provide localized results such as pressure distribution of fluid. Okay, how the stress and the structural deformation happen in the structures. And then also you can have a better visualization on the um, you can have a bit visualization on the hydraulic system, and then also the you can speed up the construction properties. Okay, next is the multi-physics integrations, where you can combine the fluid engineering, you can combine a structural engineering, you can combine the thermal engineering, wind and so on. Okay, so in a one model, so you can also you can also, okay, when you have a different countries, okay, you can simulating, okay, what is the situation in this country, what is the situation in this country, and what is the situation in a certain countries. Okay, sometimes there are countries that have very cold weather, sometimes there are country with a very hot weather, so you can playing and also you can manipulating the design very efficiently. Alright, next is the enhanced safety and reliability. Okay, identify. So for that, you can identify what is the safety protocol that you can be implemented. Okay, and also when you are modeling in the software, you can ensure that it is safe before it have been constructed, and also you can keep on the material system. Sorry, you can improve the system robust before you can apply or you can implement the materials in the systems. Okay, next slide. Okay, so we have know all the advantage that related when we are using the finite element method and also the traditional methods. Okay, so we have the advantage. Okay, lot of advantage. Okay, when you are using the FEM. Now, when it comes to the challenge, okay, everything that have a positive feedback, sometimes they also must have a negative feedbacks. Okay, so in our session today is more focused on the challenge. Okay, we have various advantage. Then for the first challenge is the computational complexity. Okay, as you see, there are a lot of interaction between what we call multi-field area. You have the structure, you have the geotech, you have the water. So the problem is you need to have a very high processing power on a computer and a memory requirements if you want to building a larger models, meaning that you need your computer must be a very super high end computer, because all the calculation process, okay, all the calculation process will take a longer time and it will create a very high processive powers of the computer. Okay, and then the accuracy of the input data. Okay, because the accuracy of the input data, it is depends on the accuracy of the materials. Okay, sometimes the material will exist a different properties, and also the geometry also must be precise, and then boundary condition also must be reliable for you to get the accuracy of input data. Meaning that in the store, in the one tree of the data, if one part of the branch is broken or the data is wrong, so it will affecting the whole accuracy of the input data. So that's why it is becomes the challenge in the implementation. All right, next is the meshing issues. Meshing issues means that you want to convert the elements, the smaller elements. Okay, that is the mesh. So you can creating an the challenge is by creating an optimal mesh to balance the accuracy and computational costs. Okay, meaning that you can using a smaller mesh, but the time taken will be higher. Okay, but if you use the coarser mesh, the time taken for the simulation will a little bit lower, but it will be affecting your final result. Okay, so when it comes to final result, you have two different. So that is come to the next challenge is the convergence problem. Convergence problem means that you are testing the meshing size and you see the result. Okay, then you need to have a graph that is increasing, and when it comes to a certain suitable mesh, the movement of the graph is not everywhere, meaning that it is almost reaching a one final meshing issues, meaning that you can use a coarser, you can use fine, and then when there are terms what we call a convergence problem, meaning that the final result must be reaching a one values that is stable. So that is what we call the convergence result, meaning that the mesh of already optimum. Okay, then you can only use the meshing size to simulate any others models. But the problem is if the convergence, you have the problem where the solution, okay, the iterative solution is fail to converge, so it will continue up and down without any final result. So that is will become your biggest challenge in the FEM. Okay, next is the interpretation of the result. Okay, requires, okay, when they will give you a result, so you need to have a very good theories, core values, or what we call, you need to have them some expert on to ensuring that the result are correct, free from errors. Meanings that you still need to validate your result. Okay, either it is a manual calculation or by the expertise. Okay, that your result is correct and the answer is logical. Okay, so that is the interpretation of result. And the last one is the software and training costs. Okay, I believe these courses is not being taught in the most of the engineering fields. I believe in the class. Okay. Yes, we still have to learn the software, but not this finite element method software. Some of the software also is very expensive, and then also there are not so much lectures that can give training on that particular courses. Okay, so that's why the software and training course is become the main challenge also in the implementation, and also because the licensing fee of the software and the advanced tool is very expensive. Okay, and then also the users need to become always keep on playing with the software just to make them masterize their skills. Okay, next. All right, so we have the advantage, also we have the challenge, and also we have a lot of various of condition that will affecting the implementation of the finite element method in the engineering. So how we want to bridge the gap, okay, how we want to elevate the gap, how we want to eliminate the gap. Okay, so basically it is where the importance of collaboration between the academic and industry, right? Because for the between the collaboration, they can encourage the practical application of the lecturers of the students in a real world projects, meaning that the industry always have a problem in terms of problem solving, but also the academia are having a problems in terms of the real world experience. So both of these can be combined and the gap will be elevated. Okay, and then also it will help the industry. Okay, the industry also can adopting a cutting edge FEM advancement, for the efficient solution. Meaning that sometimes the university have the software, but the industry doesn't have the software, and then the software is very expensive, so the industry cannot purchase it. So by then the industry collaborate with the academic or the university, okay, so that they will have a place to run the simulation. Also the university have a training so they can improve their skills later on. And then the next suggestion to bridge the gap is through enhancing education and training in finite element method. So basically, it can start to design a specialized courses just for the students to be aware with the finite element method, and then the student can go participating any hands-on workshop. Even not the student, even the lecturers also can be participate in enhancing the education in terms of the finite element method. So to bridge the skill gap with the internship and collaborative projects, meaning that during the industrial trainings of the student already been prepared using the software, and then they can use it to continue the work. Right, and then the third one, how to bridge the gap, advancement in computational technologies. So, in the field of the FEM, you will need to have a very good computer, high-end computer, and this is where you need to leverage the high performance computing system if you want to do a faster simulation. Okay, if your model is very small, the calculation will not so be difficult. So by then the simulation will be faster. Okay, but if the object is too complex, okay, it will increasing your time and you will need to have more advanced power of the computational. And then also, like I said, the integration of AI nowadays, okay, and also the machine learning has been automated in increasing the faster simulation. And yeah, when you are working with lot of engineers, you can collaborate with them through what we call a cloud base. And I believe most of the IT have this system cloud base. It is something like you are sharing the file between each other. Okay, so next slide. All right. So as the conclusion, what is the FEM? So basically, this is the final conclusion. Okay, FEM is just breaking down larger objects into the smaller parts. And then why it is so important? Because for sure we want to have elevating the cost and time, and also the challenge. Okay, what are the challenge? And then I believe it is more on the computation itself and also the price. And my final thought is this computational is already been used in industries. So try to explore in terms of to increasing your skills. Right. So that's all for me for the session. I will give back to the moderator.
Okay. Thank you. Thank you, Mr. Muhammad Zulhari, for the insightful presentation. It was really wow. Now it's time for our questions and answer sessions. I will have received a few questions from our engaged audience. Let's start with the
Okay,
first.
I have seen a comment from Garrett Hisham. Okay, for the Garrett Hisham, what are the critical engineering analysis tool or technique highlight in the webinar, and how they impact modern civil engineering projects? Okay, what are the critical engineering analysis tool or technique? Basically, engineering analysis tool, when you meanings by a tools, for sure, in the engineering, we have what we call a modern tool usage in the program learning outcome. So I believe what the Gary Hisham asked is about the tools. So basically, the tools is the software, and then as I've been mentioned, okay, I will not specific to any specific software because I believe sometimes it will affecting the credibility of the software. Okay, so I can say the analysis tools is the software. Okay, you can use any software as long as it is an FEM software. And the technique, okay, the technique in the software. So basically, it is being presented on the FEM workflow. how the techniques is used. Okay, basically the technique is standard, meaning that you need to start from the small discretization of the elements. You need to put all the boundary condition. You need to have all the material properties behavior, and last is the post processing for the final products. Okay, cool. And how do they impact modern civil engineering projects? Um, I believe, okay, how do they impact? Even though we have a lot of advancement in our technology, but I believe the handmade or what we call the hand calculation is still being using, meaning that we cannot depend 100% on the computer because sometimes it also can give an error or can give a wrong calculation. So by the end, it is still need to have manual calculation by the expert. Okay, any question? Okay, Nikaya, I give back to the moderator.
Okay, I see there are no more questions. As for now, we can come to a conclusion, and I want to thank you for the clear explanation, Mr. Muhammad Zulhari. As we conclude today's session, I want to express our gratitude for your insightful presentation on the bridging the gap. That was the topic, bridging the gap, infinite element method application in civil engineering, of which I've also learned it is FEM. In short, your experience has really helped us so much and has certainly added value to our understanding of this important topic. On behalf of Massa University, I extend sincere thanks to all the participants for joining us today. Hopefully, the presentation was beneficial for everyone. For all the audience and viewers, we invite you to explore more about our programs, especially in the Faculty of Engineering, Built Environment, and IT. And join us on our open day. Details can be found on our website. Once again, thank you, Mr. Muhammad Zurhari, for your
Yeah.
time and engaging session. And goodbye, everyone. And we look forward to having you with us again in the future Viber sessions. Thank you so much. Alhamdulillah.